Softswitches emerged as part of the telecommunications industry's shift from circuit switched telephony, PSTN, to packet-switched, IP-based communication. Below is a clear, chronological explanation of why they appeared, what problems they solved, and how they changed telecom architecture. A soft switch, short for software switch, is a central device in a telecommunications network that connects telephone calls from one phone line to another. Unlike the massive hardware-based switches of the past, like the 4S or 5S you saw earlier, a soft switch performs these tasks using software running on general-purpose server hardware. It serves as the brain of a modern voice-over IP, VoIP, network, managing the transition between traditional circuit-switched networks and modern packet-switched networks. Core functions of a soft switch. To understand how it works, it's helpful to look at how it breaks down a phone call into two distinct parts: the control plane, signaling this is the logic. The soft switch identifies who is calling, where the call needs to go, and whether the caller has the right permissions or balance to make the call. It uses protocols like SIP, Session Initiation Protocol, or H.323. The data plane, media. This is the actual voice. While the soft switch manages the connection, the actual voice data, media, often travels directly between gateways or devices to reduce latency. The evolution, from hardware to software feature: traditional switch, example 5S, soft switch physical form massive, specialized hardware rack software on standard server/cloud network type circuit switched, PSTN, packet switched, IP/internet, scalability difficult, requires physical installation high, can be scaled virtually maintenance high cost, specialized technicians lower cost, standard IT maintenance. Key components: 1. Call agent/soft switch controller, the central intelligence that handles call routing and signaling. 2. Media gateway, MG converts the voice signals from the old school analog/digital phone lines into IP packets, and vice versa. 3. Signaling gateway, SG handles the translation of signaling protocols, like SS7 used by the 4S, so they can communicate with the IP network. Why it matters: soft switches made it possible for internet-based calling to become reliable and high quality. They allowed telecom providers to phase out the football field-sized rooms of 1970s hardware in favor of efficient data centers, leading to lower costs for international calls and the rise of features like visual voicemail and integrated messaging. How soft switches emerged. 1. Limitations of traditional circuit switched systems. Before soft switches, networks used large hardware-based switches such as 4S, long distance, 5S/DMS100, local switching. These systems were hardware-centric, proprietary, expensive to maintain, difficult to scale, dependent on dedicated time division multiplexing, TDM. Circuits as services grew, data, early VoIP, broadband, the inflexible TDM architecture became a bottleneck. 2. The rise of packet networks, IP. In the 1990s, IP networks exploded due to internet growth, Ethernet cost reduction, ability to carry voice as VoIP packets, growing need for multi-service networks, voice plus data plus video. Telecom operators realized they no longer needed separate networks, one IP network could carry everything. Voice no longer had to be switched by monolithic circuit switches. This created a technological gap: we need a way to control voice calls over IP just like class 4/5 switches did over TDM. 3. Decoupling call control from media, a key innovation. Traditional switches combined call control, signaling, routing, features, media switching, voice paths. IP networks made it possible to separate them. This separation is the foundation of soft switch architecture. Soft switch equals call control/service logic. Software media gateway equals hardware that handles the actual audio packets. This model is more flexible and scalable than monolithic TDM switches. In the evolution of telecommunications, the soft switch was the great uncoupling. While legacy systems like the 5S were monolithic, where the hardware and software were inseparable, a soft switch breaks the system into two distinct layers: control logic and the switching fabric. This is often referred to as the split architecture or the gateway control protocol model. The separation of church and state. The core philosophy of a soft switch is to treat the brain, the logic, and the muscles, the hardware that moves bits, as independent entities that talk to each other over a network. 1. The control logic, the call agent. This is the software part of the soft switch. It is also known as a media gateway controller, MGC, or call agent. Function: it handles the intelligence, deciding where a call should go, checking if a user has a balance, managing caller ID, and handling call waiting. Protocols: it uses signaling protocols like SIP, Session Initiation Protocol, or H.323 to communicate with other controllers. Hardware: it usually runs on standard high-performance servers, COTS, commercial off-the-shelf, rather than specialized proprietary hardware. 2. The switching fabric, the media gateway. This is the hardware part. It is often called the media gateway, MG. Function: this is the switching fabric that actually transports the voice data. It converts the physical stream of data from one format to another, example converting traditional TDM voice from a copper wire into IP packets for the internet. Action, it doesn't know who is calling whom, it simply opens or closes gates based on instructions from the control logic. Why this separation changed everything: scalability. In the old 5S days, if you needed more switching power, you had to buy a massive, expensive proprietary module. With the Softswitch, if your logic is slow, you upgrade your servers. If you need more fabric, you add more gateways. Cost, by moving the logic to standard servers, providers stopped being locked into specific hardware vendors like Lucent or Nortel. Interoperability, because the logic and fabric communicate via standardized protocols, like MGCP or Megaco/H.248, you can theoretically use a control agent from vendor A to manage a switching fabric from vendor B. Analogy, think of a traditional switch, 5S, like a specialized calculator where the buttons and the processor are one solid piece. A soft switch is like a smartphone app, the logic, running on a generic screen, the fabric, you can update the app without throwing away the phone. Standard communication protocols. To make this separation work, the control logic must talk to the switch fabric using specific languages. H.248, Megaco, the industry standard protocol used specifically for a controller to tell a gateway what to do with a media stream. SIP, used between different soft switches to coordinate calls across the global network. For standardization, H.323 rightward arrow SIP rightward arrow MGCP rightward arrow H.248, Softswitch emergence accelerated when standards matured, early VoIP signaling H.323, 1996, first large VoIP standard but complex. Softswitch-oriented protocols MGCP, Media Gateway Control Protocol, Megaco/H.248, Media Gateway Signaling SIP, Session Initiation Protocol, became the dominant protocol for Softswitch and VoIP networks. As SIP matured in the late 1990s and early 2000s, Softswitch deployment accelerated globally. The primary protocol used between a Softswitch and a media gateway is H.248, also commonly known as Megaco, Media Gateway Control. While the Softswitch, the brain, handles the logic and routing, it uses this protocol to tell the media gateway, the brawn, exactly how to connect and process the voice traffic. 1 H.248/Megaco. This is the industry standard. It was developed as a joint effort between the ITUT and the IETF to replace older, less efficient protocols. How it works: it uses a master/slave model. The Softswitch, acting as the media gateway controller, sends commands to the media gateway to create, modify, or release terminations, connections. Why it's used: it is highly scalable and supports complex multimedia services beyond just simple voice calls. 2 MGCP, Media Gateway Control Protocol. Before Megaco became the dominant standard, MGCP was widely used. Nature: like Megaco, it follows a master/slave architecture. Status: it is still found in many legacy VoIP networks, but it is generally considered less powerful than H.248 because it is more restricted to basic telephony functions. Key concept: the master-slave relationship. In this architecture, the media gateway does not think for itself. It waits for the soft switch to send a message over the protocol to perform specific actions. 1 Detection: tell me when the user picks up the phone. 2 Signal generation: play a dial tone to the user. 3 Connection: map this incoming analog circuit to this specific IP address using the G.711 codec. Summary of protocols in a soft switch environment. Connection path protocol used soft switch to media gateway H.248, Megaco, or MGCP. Soft switch to soft switch SIP or SIP-T. Soft switch to signaling gateway SIGTRAN, often over SCTP. 5 Telecom operators wanted lower cost soft switches. Dramatically cut operating expenses because they use COT servers instead of proprietary hardware. Reduce power and space requirements. Simplify upgrades, software-based, support IP networks that were already being built for data services. This made soft switch migration economically unavoidable. Moving from hardware-centric switches like the 4S/5S to soft switches drastically cuts operating expenses, OpEx, because it shifts the entire business model from buying and maintaining specialized machines to running software on standard computers. Here are the primary drivers of those cost savings. 1 Drastic reduction in physical footprint. Legacy switches like the 5S are massive. They require entire rooms, sometimes whole floors, of a building. Real estate: a soft switch runs on a few racks of standard servers, allowing companies to close down large central offices or lease out the extra space. Power and cooling: traditional switches use power-hungry proprietary circuit boards. Soft switches use energy-efficient data center hardware. Some providers report a 10:1 reduction in power and cooling requirements. 2 Standardized hardware, COTS, with the split architecture, separating logic from fabric, carriers no longer have to buy proprietary hardware from a single vendor. Off-the-shelf servers: the control logic runs on standard COTS, commercial off-the-shelf, Servers, like Dell or HP. If a server breaks, you replace it with a standard part rather than flying in a specialized technician with a vintage 1990s circuit board. No vendor lock-in, since the Softswitch, Logic, and Media Gateway, Fabric, communicate via open protocols, Megaco/H.248, a carrier can buy the brain from one company and the muscles from another, forcing vendors to compete on price. 3. Remote management and automation. Legacy switches often required hands-on maintenance. If a line card failed or a configuration needed changing, someone often had to physically go to the site. Centralized control. Soft switches are managed through web interfaces or APIs. A single technician in a different city can manage dozens of soft switches simultaneously. Software updates. Upgrading a 5S often meant physical hardware swaps. Upgrading a soft switch is a software patch, often done with zero downtime. 4. Efficient use of bandwidth, LCR. Soft switches are built for least cost routing, LCR. Intelligence. The control logic can look at the destination of every call in real time and choose the cheapest possible path, example routing a call over the internet instead of an expensive long-distance trunk. Packet efficiency. Traditional switches hold a circuit open even during silence. Soft switches use packet switching, meaning network resources are only consumed when someone is actually speaking. 5. Simplified triple play integration. In the old days, you needed separate networks for voice, video, and data. Unified network. Because a soft switch is IP-based, it runs over the same fiber network that carries your internet and TV. Maintaining one network is significantly cheaper than maintaining 3 separate ones. Comparison summary. Expense category. Legacy, 5S/4S, soft switch power/cooling high, proprietary circuits, low, data center standards, space huge, specialized.